Hi everyone, so welcome back. Thank you very much for being willing to watch this video. So again, just to reiterate from the last video, the reason that I make these is not only because I want to be transparent about what we're learning in class with parents and children, but also because I believe that parents need to have the toolbox necessary to help their kids. I understand that math is different in different places, but it's also like math was a long time ago for some of you, so that's okay. So that said, in Unit 2, we are working still in our Math 01 notebook, and we're working on comparing numbers again. Okay, so in this unit, we have 5 main goals. The first one is to identify patterns. We will represent patterns, compare them, and then we will build and compare algebraic expressions, okay? So I absolutely understand that that feels like a lot for one video. I'd like you to keep in mind that this one video is a very condensed version of what we will be doing in class within a week and a half, maybe 2 weeks, depending on how the kids are doing. So let's go through this. Okay, so the first thing is identifying the patterns. So now by grade 7, your children should have have had ample opportunities. Like, I can't stress this enough. They should have been looking at patterns left, right, and center for a long time. So they should be able to look at a picture or a pattern of blocks and be able to say, well, miss, I see a pattern of 3, 6, 9. So what we have is a term of day 1. So it's day 1, day 2, day 3. So it goes up by 1 day every time. And then we have 3 presents here, 6 presents here, and 9 presents here, okay? So then that would be the value under here. If you were talking about a chart or a graph, this would be your X value and this would be your Y value, okay? And then just under it, there's a quick explanation. So again, looking at this pattern right away, your child should be able to say, okay, there's a pattern, 3, 6, 9. Part of identifying patterns in grade 6 is also identifying what is not a pattern. So if I were to give your child, for example, 2, 8, 72, 69, they should be able to say, well, madam, there's no pattern there. Okay, so the next thing is representing patterns. Before we learn algebra, we represent patterns in lots of different ways. We'll be focusing on 3 different types. Method 1 is a concrete representation. So when we say concrete, we're not talking about the stuff on your driveway. What we're talking about is being physically able to represent a pattern. So either you're drawing it out, you're using maybe blocks or pictures, or you're just representing it physically using tools, okay? So this is the one that kids are the most used to. This numeral representation form is the one that is just absolutely the most important because this is the one that will help us with algebra. So again, the term normally represents like a unit of time normally, or it could just be like term 1, 2, 3, 4, 5. This is the one that's like our constant. This is the one that changes. So the value, remember on day 1, we had a value of 3 gifts. On day 2, we had a value of 6 gifts. And on day 3, we had a value of 9 gifts. So again, this is the one that, if anything, we need to have figured out. Here, we're looking at your child's ability to communicate using mathematical words or communicate mathematical concepts using words. So here we're saying in this pattern, each time the term increases by 1, the value increases by 3. The term is represented by the number of days, so term is number of days, and the value is represented by the number of presents. So now I know that seems like a simple sentence, but a lot of kids actually have a really hard time writing this sentence. So anytime that you see your child working on a pattern or you see a pattern, just ask them really quickly, like, hey, can you explain that pattern to me? And notice how they explain it, whether or not they're using the right vocabulary, if they're speaking in full sentences. Are they actually using the words term and value, telling you what the term and the value are in that example, in that specific example? So just be mindful of those words, and let's try getting your children to use real mathematical concepts to explain what they're seeing in full sentences as well. So the next thing It's comparing patterns. So we would do something like, here's a pattern 1 and here's a pattern 2, okay? And oftentimes I kind of make it about like work, okay? So I say, well, so your neighbor needs you to shovel their snow. If you work 1 hour, they'll pay you $3. If you work 2 hours, they'll give you $6. And if you work 3 hours, they'll give you $9. It's a terrible job, but it's child labor, so what can you say? Pattern number 2, maybe your neighbor now wants you to cut the grass, but they'll give you $6 for $1 hour. 2 hours would be $8, and 3 hours would be 10 hours. And then so my question will become, well, if you work 4 hours, how much are you being paid? Okay, and which job would you rather have, the snow or the grass? So we could just work that out really quickly together. Let's even say that they're working 6 hours. So what the kids would normally do is either take their picture or drawing and bring it up and keep continuing to grow it. They could skip count, or they can do the following. I want to know for 6 hours, so I know 4, 5, 6 continues in my term, and then 4, 5, 6 continues my term. That one is really ugly. Okay, so if I extend this line, I know that this is plus 3 here. This is plus 3 here. So that means that for 4 hours of work, I should be making $12. For 5 hours of work, I should be making $15. And then for 6 hours of work, I should be making 18 hours. Similarly, we're looking here. This is plus 2 and plus 2. So for 4 hours of work, I should be making $12. The same amount there. And then $14 here and $16 here. So then we could ask a bunch of questions. Well, if you were going to work only 1 hour, which job would you want? If you were going to work 6 hours, which job would you want? And then if you were going to work 4 hours, which job would you want? So your children should be able to identify that different patterns will yield different results. Okay, and then it's okay that the value is higher for one term and lower for one other. So for example, if this was me and pattern 2 was grass, pattern 1 was snow, I would work the pattern 2 job for 1 hour, but definitely the pattern 1 job for the 6 hours. Okay, so I know that that sounds a little bit confusing, but we'll definitely continue to look at that. Okay, and so again, just to reiterate, while your kids are looking to extend patterns, they normally would do something like skip counting, they would add to the T-chart the way that I have done, or they can continue drawing or using their blocks, okay? So this works for really small numbers. But the second that I say, okay, well, you need to work an entire work week, or here's 80 hours, because now you have a full-time job, it becomes really difficult. So the reason that we introduce algebra, or how we justify introducing algebra more like, is saying, well, what if we have large terms? What if you're working 43 hours? So that's your 40-hour work week and 3 hours of overtime. How much are you being paid? And then what if it's 121 hours? I don't know why you would want to calculate that, but why not? So if that was the case, you're not going to sit there all day and go 3, 6, 9, 12, 15 and keep going. No, that'll take you forever. So then that's when we introduce the kids to this wonderful concept of algebra. Okay, so if you're using any American online websites to find extra work, which I hope you're not doing, let me know if you need extra work. But if you do decide to search for anything, or you want to buy resources to support your child even further, in the States, this is actually called pre-algebra, because they're not actually solving yet. Okay, so this will be pre-algebra level 1. So we use this tool called Dino. So most of the kids want to say this word here as dino, but I have obviously just aged myself by telling you about the Flintstones. Dino was Fred's pet, and I loved him, so we call him Dino, not Dino, and then it's a really cute argument that we have with the kids every year. So Dino is phenomenal. So the DI stands for the difference between the terms, okay? So like we saw in the last pattern, we can look on the side of these numbers, on the value side, to figure out what the difference is. So the difference between 20 and 25 is 5. The difference between 25 and 30 is again plus 5. The difference between 30 and 35 is again plus 5. The nth term. So all the nth term means is that you have a variable and we're always going to have it n. So now, as most of you know, we can use any variable in the alphabet that we want. There is no particular reason that I am using n besides the fact that it makes a cute name Dino. So if the kids decide they want to use X, if they want to use T, if they want to use D, they are absolutely welcome to do that. I only suggest using the nth term because it is helpful for this. And then this one is term 0, so it's the one before the number 1. So you actually have to extend your chart to get the 0 and figure this out doing some math. So let's work that out together. Just so we all are on the same page on how to do algebra. So again, the DI is the difference between terms. So the first thing we would do is calculate here and say, okay, 10 to 14, we have a plus 4. And then 14 to 18, we have a plus 4. So that means that my DI, my difference between terms, is plus 4. My N, all I do is bring it down. And then my 0 term. So I have 1, 2, 3 in terms. I need to go 0. And to figure out what this is, all I do is the opposite. So this is plus 4. This is plus 4. That means if I'm going down, it's plus 4. So going up is the opposite, minus 4. So it would be 6, because we know 6 plus 4 is 10. So then we write plus 6. And there we have it. 4n plus 6. Now you might have some older kids in high school, or you might remember from yourself, algebraic expressions normally require some rise over run stuff. We don't need to do that with these kids. We're not there yet. Okay, let's do another one. So again, our difference between the term is the DI. So we are looking at the difference here. It's not quite 10, it looks like it's 8. And then 32 and 40, again, plus 8. So then we need to figure out, well, what is this here for term 0? Sorry. So something plus 8 equals 24. Okay, sorry. So 16 is our term 0. So this difference is 8. We would bring the n down, and then we have a plus 16. So we end up with 8n plus 16. And there we have it. We have our algebraic expression. Okay. So then we would have to solve and compare. So let's say that we're looking for term 5, okay? All we would need to do is take 5n plus 100, and then we would put our 5 where the n is. So we would say equals 5 times 5 plus 100. This is where the students and I would have to have a conversation about bed mass. So we'd know we would multiply first. 5 times 5 is 25. Plus 100 is 125. Let's do the next one. 10n plus 80. And again, we're looking to solve term 5 equals 10 times 5 plus 80 equals 50 plus 80 equals 130. So now again, I always like to use the idea of financials. Which one of these, if they were jobs, would you rather want to work 5 hours for? And hopefully you said the one with the $130. Okay. The reason that I always choose money is just because I think it's easier to relate to, and kids kind of often really understand that. Okay, the next slide, again, solve and compare. And again, we're looking for term 5. So you always start by writing the full thing, 7n plus 21. So 7 times 5 plus 21 equals 35 plus 21 equals 56. And then this one is 9n minus 3 equals 9 times 5 minus 3 equals 45 minus 3 equals 42. Now again, in terms of money, if you're having one job, if you're working this job for 5 hours or this job for 5 hours, hopefully you decided that you would want job number 1 because it pays a little bit more. Okay, so that's the end of the video. It is an entire unit of math covered in one video, so I did try to cram it all in there. If you have any questions about any of this, feel free to shoot me an email, let me know. If you think your child needs any help at any point, or you notice that they don't exactly have the right wording or aren't exactly doing what you're seeing in this video, just let me know, or tell them to let me know in class, and I'd be more than happy to support that process. Okay? All right, well, thank you.